Alright, hey students, welcome back. It's my first lesson for 2016. This is Unit 4, Lesson 2, and we're going to be talking about solving one-step equations. And y'all, it's really important that you pay attention because this is a concept that you're not only going to be covering this year, but you're going to be covering it next year in 7th grade, in 8th grade, and all the way through high school. So make sure you pay attention. I think it's pretty easy once you catch on to it, but you really need to pay attention to the examples. First thing let's do is let's talk about some of the vocabulary. So I want you to go ahead and you fill in the definitions on your homework sheet. You just write them in the blanks.
The first one is a mathematical sentence that contains an equal sign. We call that an equation. Alright, so anytime you see anything dealing with a mathematical sentence that contains an equal sign, we call that an equation. And when you think about an equation, has that EQU, which is a term that means equal. So in an equation, both sides of the equal. The second definition, and you're going to be hearing me talk about this a lot, is inverse operation. Alright, an inverse operation is the opposite operation. So when you look at, we have 4 basic operations. We have addition, subtraction, multiplication, and division. Addition is the opposite of subtraction, and you can also say that the other way, subtraction is the opposite of addition. Multiplication is the opposite of division, and you can also say that the other way, that division is the opposite of multiplication. It's very important as we start studying solving equations that you understand with the inverse operation, because we're always going to be using the inverse operation, and it just means the opposite operation. Alright? The value that makes us an equation true, we call that a solution, or the answer to the problem. You're going to hear Ms. Juhan and I use that word a lot, solution. To find the value of an expression, we say it's to evaluate. Alright, evaluate. So a lot of times we're going to be evaluating expressions. That is when we're going to find the value of that expression. We're going to narrow it down to the simplest terms, and most times it's going to be one number. And the last one is the process of replacing a variable in an expression with its actual value. We call that substitution. Alright, so 1, 2, 3, 4, 5. Those are 5 vocabulary words that you're definitely going to need to know in Lesson 2. And so make sure you're very familiar with those because we're going to be using them a lot just as we're talking about the material.
Let's look at introduction number 1. This video kind of has 2 parts. This is the first part, and then the second part you'll see later on.
But the first thing in this part is we're going to be looking at some different equations and inequalities, thinking back to last week. And we're going to be talking about them a little bit as far as what the solutions mean. The directions tell us to identify a value for the variable that would make each equation or inequality true into a true number sentence. Is this the only possible answer? So we need to see if it's the only answer that will work. And then we'll state that using inequality symbols. So let's look at our first one. 3 plus g equals 15. So let's think, what number plus 3 will get me 15? Well, if you know your basic facts, you know that it's 12. And since it's an equation, we know there's only one solution. So 12 is the only value for g that will make the equation true. It is very important that we put that word only. We only have
one solution to an equation.
I can't put any other number or substitute any other number in for g and get a true equation. Because 12 plus 3 is the only way I can get to 15 here. Alright, now let's look at the inequality. 30 is greater than 2d. Alright, so we want to make this inequality true. First of all, I need to recognize that this means multiplication. So 2 times what will make this inequality, make this expression less than 30? Well, I can look at it and I know 2 times 15 will equal 30, but I don't want to equal 30. I want to be less than 30, which means I need d to be anything less than 15. Alright, so I'll say that the inequality is true when d is any value less than 15. Alright, so if I plug in 14 here, 2 times 14 would be 28, and 28 is clearly less than 30. If I put 13 in there, 2 times 13 is 26, and so 26 is less than 30. If I put a value greater than 15, let's say I put 16, I'll substitute in 16 here. 2 times 16 is 32, which is not less than 30. So that wouldn't be a true statement. So the only value I can substitute in for D is going to be any value less than 15. So there's more than one solution here, as opposed to equations when I only have one solution. Looking at example C, 15 divided by what would get me something less than 5? Well, first, I know that 15 divided by 3 would equal 5, but I don't want to equal 5, I want to be less than 5. So I will say that the inequality, let's say if I put a 2 here, 15 divided by 2 is 7.5. That's not less than 5. So let's put a value, let's do 4. 15 divided by, well, let's say 5. 15 divided by 5 is 3. 3 is less than 5. So I can say that the inequality is true when f is greater than 3. Alright? Because if f equals 3, then that will get me 15 divided by 3 will equal 5. So I don't want to equal 5, I want to be less than 5. So I need the variable to be a value greater than 3. Alright, looking at D, the last example. In order to make this inequality true, I need m. So the inequality is true when m is any value. And let's say to make it equal, it'll be 8, because 50 divided by 8 will equal 42. And if I want to be greater than that, I can substitute in I need any value less than or equal to 8. Alright, so there we're just talking about some different equations and inequalities and looking at the difference. Let's look at the second part of our video where we're going to be looking at actually solving the solutions to the problems, to the equations. Make sure that you do the independent practice for part 1 before you move on to the introduction part 2. Alright, and looking right here at the first problem, it tells us to calculate the solution. We have a plus 2 equals 8. So what number plus 2 equals 8? Now, a lot of us can look at this and we know the answer is 6, but we're going to prove that using the models. Alright? So first I can say I have 2 equal models, and since an equation means equal, I will make the top bar equal to 8. So if this bar equals 8, that must mean this bar equals 8 as well. And I'm going to write it A and 2, which will mean A, whatever A is, plus 2. Alright? So if I want to get A all by itself, I would need to take away 2. I would need to subtract that out. And if I do that to my second bar, I also need to take 2 or subtract 2 off of my other bar. So that way I'm left with 2 equal bars here, and this is A. And then I think if this bar was 8 and I subtracted 2 from it, that must mean the remaining bar would be 6. Alright, so that's how I figured it out. And the way we did that, what we did is we used the inverse operation. Instead of adding 2, we subtracted 2 from both sides. So I subtracted 2 from A plus 2, and I also subtracted 2 from 8. And 2 minus 2, that equals 0, so that gets eliminated. And I'm left with just A. And then on this side of the equation, I have 8 minus 2, which equals 6. And that's how I know that A must equal 6. So filling in that sentence at the bottom, to solve an one-step equation, you have to perform, let me use a different color here. You have to perform the inverse operation to both sides. And it's very important you do it to both sides of the equation. Because remember, an equation is like a balance. You have to keep it balanced. If I took 2 away from one of my bars, in order to keep it balanced or equal, I had to take 2 from the 8. So whatever I did to one side of the equation, I had to do that to the other side. And always look at your equal sign as the dividing line. That's where our dividing line is, on one side of the balance and the other side of the balance. So now that we know that we have to do the inverse operation, we should be able to solve these next couple of problems pretty easy. So I'm going to guide you through the guided practice, and then you're going to do the independent practice on your own. Alright, so I do the inverse operation. I always draw me a line down the equal side. So that way I know whatever I do to one side of the equation, I must do to the other side of the equation. It's very important you understand that. Otherwise, they won't be equal anymore. Alright, so here I have E plus 12 equals 20. I want to do the inverse. So since it says addition, the inverse, or the opposite of addition, is subtraction. So instead of adding 12, I'm going to subtract 12. And I have to do it to both sides of my line. So I subtract 12 here as well. Alright? 12 minus 12, that's 0. And I'm left with just my E. For Eric, huh? And 20 minus 12, that's equal to 8. So my answer is E equals 8. Now, always, always check your answer to make sure it's correct. So here, I go back to my original problem. Instead of E, I can erase that E and put 8, since now I know that E equals 8. And I check it to make sure it makes sense. 8 plus 12 equals 20. Is that true? Yes. So I know I got it correct. Always, always check your work by substitution. Alright, looking at our second example. Again, I draw my dividing line down the equal sign. Now remember, whatever I do to one side, I have to do to the other side. Minus 10, the inverse of subtraction is addition. So I'm going to add 10 to both sides. Alright, minus 10 plus 10. Those cancel each other out. And I can bring down my F. And I'm left with just F by itself. On this side of the equation, 15 plus 10 is 25. So I get that F equals 25. I always go back to my original problem. I substitute in my value for F, for my solution. So F equals 25. I'll put 25 here, and then I check. 25 minus 10 is equal to 15. So that checks out, and I know I got my question right. Alright, this next one is a little tricky because we can't use the inverse operation. Alright? Well, we can, but we'll talk about that later on in the year as far as how do we solve a subtraction problem when the variable is the second term in the problem. So since my variable is the second term, I can't simply do inverse operation because if I add 15, well, let's just try to solve it using inverse operation. Alright, I draw my dividing line, and I'll say that the opposite of subtraction is addition, but if I add 15 to both sides, on this side I can get 30, because 15 plus 15 is 30, and 9 plus 15 is 24, and I plug in 24 here. 15 subtract 24, that wouldn't equal 9, so that couldn't make sense. So in these problems, I have to use substitution to solve this problem. I have to think, 15 subtract what number equals 9? Well, I know that 15 subtract 6 would equal 9. Because 15 subtract 5 would equal 10, so I'll take one more away. I'll get that x equals 6. And when I check that, I do get a true statement that 15 subtract 6 does equal 9, and it checks out. Now that is only when the variable is the second number in a subtraction problem or a subtraction equation. Because if we go back to this problem, number 2, F, the variable, it was a subtraction problem, but the variable was the first term. In number 3, the variable is the second term. So I have to solve it differently. Alright, looking at number 4, divided by 8, g divided by 8 equals 3. The opposite of division is multiplication. So I would multiply 8 to both sides of my equation. And so that'll cancel out my 8's. And I would have g equals 3 times 8 is 24. I can always go back to substitute. Instead of putting g, I'll put 24. 24 divided by 8 equals 3. It does check out. Alright, number 5 is a multiplication problem. 3 times m equals 21. So instead of multiplication, I have to do the inverse, which is division. So I will divide by 3. Divide by 3. Alright? 3 divided by 3 is 1. And I know that if I multiply 1 times any number, I will still get that number. So this is m by itself. Equals 21 divided by 3 is 7. Alright, I can always come back to substitute. Instead of putting a m here, I will substitute in using parentheses my 7. And 3 times 7, it does equal 21, so it checks out. Alright, number 6 is another tricky problem just like number 3, where we have to use substitution in order to solve it. At least for now, until we get later on in the year. 24 divided by y equals 6. So, in a division problem, when the variable is the divisor, like here, The variable is the second term in the equation. I have to use substitution, so I have to think 24 divided by what number equals 6? Well, 24 divided by 4 equals 6, so I will say that y equals 4. And I always check my answer by substituting in my solution for y. And I check 24 divided by 4, does that equal 6? You bet. Alright? So it checks out. Always remember on like subtraction problems and division problems. If the second number is a variable, do not use inverse operation. That's only when you're talking about subtraction and division problems and the second number is a variable. Alright? If the first number is the variable, you can use inverse operation. Alright? And with addition and multiplication problems, you can always use inverse operation every single time. Alright? Well, that's all I have for you today. Do not forget to do the independent practices because we will check those answers tomorrow when you get to class, and you will not receive a stamp if you do not complete the independent practice problem. Alright? Well, that's it. Over and out. Peace.